API authentication is the process of verifying the identity of an application or user before granting access to an API. It's a crucial security measure to protect sensitive data and ensure only authorized parties can interact with an API. There are several different ways of doing API authentication. We will start with the basic authentication method. Basic authentication is a simple method where the client sends a username and password with each API request. This simplicity makes it easy to implement and understand for developers, contributing to its widespread usage in various applications. However, it lacks advanced security features and can be vulnerable to brute force attacks if not properly implemented. Implementing strong password policies can mitigate these risks and enhance the security of the authentication process. Basic authentication is best suited for internal APIs with low-risk data, as it provides basic identity verification and is suitable for scenarios where security requirements are less stringent. For external-facing APIs handling sensitive information, more robust authentication mechanisms should be considered. As Basic Auth method does not offer robust security, we will look at using API keys for authentication. API keys serve as unique identifiers that authenticate a client application or user to an API. This unique identification allows the API to distinguish between different clients and track usage and access permissions effectively. They're easy to implement and can be quickly integrated into client applications, streamlining the authentication process for developers. Their simplicity makes them an attractive option for applications that require a straightforward authentication mechanism without the overhead of more complex systems. API keys provide basic security measures, but can be vulnerable if leaked or shared. It's essential to implement additional security measures, such as rate limiting and IP whitelisting, to mitigate potential risks. Regular key rotation and usage monitoring are also recommended to enhance security and prevent unauthorized access. API keys are commonly used for public-facing APIs with low-risk data exposure, as they offer a simple and efficient method of authentication. However, for APIs handling sensitive information, more robust authentication mechanisms should be considered. Implementing OAuth 2.0 or JWT-based authentication can provide enhanced security and flexibility for protecting sensitive data in public APIs. Let's take a closer look at OAuth 2.0 and explore how it offers improvements over other authentication methods. OAuth 2.0 allows users to grant limited access to their data without sharing their credentials. This approach enhances security by minimizing the exposure of sensitive information while still enabling seamless access to authorized resources. It uses access tokens to authenticate and authorize API requests, providing more control and security. Access tokens serve as temporary credentials that grant specific permissions to client applications, reducing the risk associated with long-lived credentials like passwords. OAuth 2.0 supports flexible scopes, enabling granular control over the permissions granted to client applications. By defining scopes, OAuth 2.0 allows users to specify exactly what data and actions an application can access, enhancing privacy and minimizing potential misuse of user data. Let's delve into JWTs and see what makes them better than other authentication methods. JWTs are self-contained, digitally signed tokens that can be used for authentication and authorization. This self-containment reduces the reliance on server-side storage and enhances security by encapsulating all necessary information within the token itself. JWTs enable stateless authentication, as the token contains all the necessary information for verification. This statelessness simplifies the authentication process, as servers do not need to maintain session state, resulting in improved scalability and performance. JWTs can be used in a variety of scenarios, from session management to API authentication. Their versatility makes them a popular choice for implementing authentication mechanisms in web applications, mobile apps, and distributed systems. The digital signature and encoding of JWTs make them a more secure alternative to traditional session-based authentication. The digital signature ensures the integrity and authenticity of the token, while the encoding protects sensitive information from tampering or eavesdropping during transmission. Another authentication method that closely resembles basic authentication is digest authentication. Digest authentication uses a challenge-response mechanism to verify the client's identity. This process involves the server issuing a nonce or a unique token to the client, which the client then combines with its credentials and sends back to the server for verification. It transmits encrypted credentials, offering more security than basic authentication. By encrypting the credentials during transmission, digest authentication mitigates the risk of interception and eavesdropping, enhancing overall security. Digest authentication includes measures to prevent replay attacks, enhancing overall security. This protection is achieved by incorporating timestamps and nonce values in the authentication process, making it difficult for attackers to reuse intercepted authentication data. Lastly, we will now explore the MTLS authentication method. MTLS is a two-way SSL/TLS authentication process where both the client and server verify each other's identity. This bidirectional authentication ensures that both parties can trust each other before establishing a secure connection. It uses digital certificates to establish a secure, encrypted connection between the client and server. These certificates, issued by trusted certificate authorities, provide cryptographic assurance of the identity of each party, enhancing the security of the communication channel. MTLS provides a robust, certificate-based authentication mechanism, offering enhanced security for sensitive API interactions. By requiring both parties to present valid certificates, MTLS significantly reduces the risk of impersonation attacks and unauthorized access, making it well-suited for protecting critical systems and data. Having thoroughly examined the various authentication methods, we will now discuss the best practices followed in the industry. Choose the right authentication method. Evaluate your security requirements and select the most appropriate authentication mechanism for your API. Implement strong encryption. Ensure all API traffic is encrypted using HTTPS to protect sensitive data in transit. Regularly rotate API keys and tokens. Periodically update API keys and tokens to minimize the risk of compromised credentials. Monitor API usage and security. Continuously monitor your API for suspicious activity and respond promptly to potential security breaches. API authentication methods are crucial components of securing web services, ensuring that only authorized users or systems can access protected resources. They play a vital role in safeguarding sensitive data, maintaining privacy, and preventing unauthorized access or misuse of APIs. If you wish to learn any of the authentication methods in more technical depth, please feel free to comment below. I will post video on that topic up next.